In today's video, I will be telling you about delta modulation. Delta modulation is basically adopted after pulse code modulation, as pulse code modulation was having some limitations. The basic limitation was the bandwidth, as the pulse code modulation signal comprises of many number of bits corresponding to its analog signal. So overall bandwidth of the signal becomes more. Now in delta modulation, what we do is we corresponds to one bit, there is only one sample. So number of samples reduces and the bandwidth of the overall signal reduces. So how it works, first we will see that. So this is the modulating signal f of t. It is in the analog nature. This signal is given to the difference amplifier. The output of difference amplifier gives the output as the difference of input 1 and input 2. So the second input is basically a feedback from the output, but first we will assume some arbitrary value so that we will start the process. Let us assume that we have assumed some arbitrary value according to this f of t. So we are only interested about the polarity of the output. So we are not interested in any values, we just need the polarity, whether the output is positive or the output is negative. Now this is a pulse generator which is continuously generating the positive pulses. This is what the pulse generator does. It produces continuous positive pulses to this balance modulator. Now this balance modulator will multiply this pulse generator input as well as the delta t, which is the output of the difference amplifier. So suppose delta t is positive, that means the difference amplifier's output is positive. The output POT will also be positive because positive multiplied with positive pulse will be positive. If the difference is negative, the output pulse is negative. So the output P naught T will be something like this. Some positive pulses and some negative pulses as per the polarity of delta T. This signal is now given to the integrator circuit, and this integrator circuit is fed to the second input of the difference amplifier. So this process now will continue. But what is the output of the integrator? When these positive and negative pulses are given to the integrator circuit, it will follow the signal in the form of steps. Suppose the pulse is positive, you will get a positive step. Then again it is a positive pulse. So 3 positive, then 3 positive, then 3 negative, then 3 negative, then 3 positive, 3 positive, and so on. So integrator output is something like this. If it receives a positive pulse, it will give a positive step, or upward step, or if it is receiving a negative pulse, then it will be going into the downward direction. That means the downward steps or the negative steps. So this signal is given to the difference amplifier. Suppose this is your FT, so it will check which amplitude is higher. Accordingly, it will give the difference. If the modulating signal's amplitude is higher than the step, you will get positive delta T. If step is higher and the modulating signal is lower, then you will get a negative delta T. So this way, this signal is generated and passed. So this signal now, this is the transmitter part which we have discussed till now. Now transmitter is transmitting these positive or negative pulses towards the receiver. So receiver first receives the pulses at the quantizer block. What this quantizer does, this quantizer receives these pulses and decides whether the pulse is positive or the pulse is negative. So basically this quantizer recognizes the polarity of the pulses. This is what the work of this quantizer. Then after the quantizer, it is given to the integrator. Obviously this integrator output is same as this, which is positive and negative steps, something like this. And then this signal is given to the low pass filter. Low pass filter, what it does, it removes the high frequency component and smoothen the curve. It will remove high frequency component and makes the curve smooth. The curve smooth means whatever the smoothen output is there, it is nothing but your modulating signal which you have transmitted. This is what the process of delta modulation. I hope it is understood. Now there are some drawbacks of delta modulation. Why? Because there are basically two types of steps. One is uniform step size, another is non-uniform step size. In delta modulation we use uniform step size. So if the step size is uniform, what happens sometimes then that if the step is following the signal, there may be some problems arises. What are those problems arises? These are the drawbacks of the delta modulation. First is granular noise, another is slope overload. So these two problems you will be better understand by the diagrams. So for the first type of drawback, granular noise, I have drawn this diagram. Let us say this is your modulating signal. Now step is uniform, so it is uniformly following this signal. So because of uniform step size, sometimes it is not actually following the waveform or could not follow the waveform properly. So such portions are not properly covered. So due to these extra steps, some noise is generated which is termed as granular noise. Second type of drawback or second type of problem which we face in delta modulation is slope overload. So slope overload is this. Suppose this is the modulating signal. This signal is having more slope. So when steps are following this signal, so it will be follow the signal something like this because of the uniformity of step size. So when it will demodulate, low pass filter will recover the signal something like this. Initially it was this, but low pass is considering the signal is this. So you may get the wrong signal. So such problem is known as slope overload. So both these problems arises due to the uniform step size which we use in delta modulation. So to overcome this, we use non-uniform step size. If we use non-uniform step size, both these problem can be overcome. So this non-uniform step size means we can increase or decrease the step size according to the desired modulating signal or according to our requirement. So these two problems will be overcome. This phenomena will be dealt in adaptive delta modulation. So now we will see what is adaptive delta modulation. It is basically a modification of delta modulation. So let us see how we have modified the delta modulated block diagram or the circuit diagram, due to which we can increase or decrease our step size. So this is the modification which we were talking about. This is known as adaptive delta modulation. As you can see the diagram, there are few additional blocks and circuits connected. This is the additional circuitry and this is the additional circuitry. So now what happens when you get the output, some positive and negative pulses, this RC works as integrator which gives you the large output and large positive and negative pulses. These large positive and negative pulses is given to this square law device which will square the pulses, whether it is positive or negative. That means the output will be the large positive pulses irrespective of the polarity. This is given to this variable gain amplifier. So now the positive and negative pulses are going to this variable gain amplifier and some gain control input is controlling the amplitude of these large positive and negative pulses. So what is basically happening? Here you are getting the positive and negative pulses, but as per the requirement we can increase the positive and negative pulses. If we increase the positive and negative pulses, we can increase or decrease the size of the step. If the size of the step is increased, we can follow the signal properly. So both the problems which we were facing in delta modulation, in which we were using the uniform step size. Now what will happen if the signal is something like this? Instead of following this, now you can follow the signal directly like this, and when you will demodulate, you can recover the signal properly. So slope overload condition as well as the signal in which granular noise was happening, that also we can reduce by changing the. Now you can see the step size is not uniform, so you can easily recover the waveform or the signal which you have transmitted. So due to this additional circuitry, that is variable gain amplifier, gain control input and square law device, this part will be responsible to increase or decrease the step of the pulses. So this is how adaptive delta modulation works, and this is what is known as the modification of delta modulation. I hope you understood the concept of delta modulation as well as adaptive delta modulation. Please do write in the comment section if you have any doubt.